Hello class, and welcome to today's algebra lesson, which is about graphing quadratic functions. By the end of today's lesson, you will be able to graph these functions in both their vertex form and their standard form. So we're going to start by graphing quadratics in their vertex form. In order to do that, we're going to use those key features we talked about in our last lesson. So the first thing we want to figure out is what our axis of symmetry is. Remember, in this case, when you have a vertex form of your function, your axis of symmetry is going to be x equals, and then the opposite of the number that is in these parentheses. So in this case, it's going to be a positive 5. Now, what that tells us about our graph is that's where our parabola gets split in half. So what you're going to go ahead and do is go over to x equals 5. So 1, 2, 3, 4, 5. And you're going to put a dashed line down that vertical stretch. So x equals 5, remember, tells us every single point where the x value is 5. So 5, 0, 5, 1, 5, 2, 5, 3, 5, negative 1, 5, negative 2, 5, negative 3. We use that dashed line because the purpose of it is just to tell us where the graph gets split in half. Technically, it's not part of our answer, but it's going to help us in a minute when we're trying to complete the graph. The next piece that we need to pull out is our vertex. Remember from our last lesson that our vertex is going to be our h value, comma, our k value. So in this case, our h value is the same as our x value, so we have a 5, and then our k value in this case is a positive 3. So my vertex, I go over 5 and up 1, 2, 3. Every single time you have a vertex, it should intersect. It should be on top of somewhere on the axis of symmetry. If those are not on the same vertical line, you have messed up either your axis of symmetry or your vertex. It has to be on that line. The next thing that it's going to be important to note is to help us remember that this negative in the front means that our graph opens down. So as I start to figure out the next few points, they should all fall below this vertex. So everything has to go down from here. Now, in order to figure out the other points on the graph, you either need to pick the left side or the right side. Personally, I prefer the right side. So what that means is you're going to go to the number that is to the right of your vertex. In this case, to the right of your vertex is 6. Then into your calculator, you would type -2 times, plugging in 6 minus 5, close those parentheses to the second power, plus 3. You would type this whole thing exactly as written into your calculator, and when you do that, you're going to get an answer of 1. So that means my next point on my graph is over 6 and up 1. Now the key thing here is our axis of symmetry tells us where the graph is cut in half. So because I have a point at 6, 1, that means I also have a point at 4, 1. Same horizontal line, and both of them are one space away from our axis of symmetry. Then, in order to continue going on with our graph, you're going to plug in another point. I'm just going to go to the next one, which is going to be 7. So you would plug in -2, 7 minus 5 in parentheses to the second power, plus 3. Again, typing that exact thing into your calculator, hitting enter, and you would get an answer of -5. So that means when we go over to 7, we go down 1, 2, 3, 4, 5. Again, parabolas are perfectly symmetrical. So on that same horizontal line, it's 2 to the right. So the opposite point is 2 to the left. Now the last piece is connecting those points into that U shape. It is a little bit more difficult for me to do this with the tablet as I am writing. So this U shape is not going to be totally perfect. But I like to just kind of start at one of my points and curve down going through, and then I come over and finish the other side of my graph. Again, Not totally perfect, but as you can see, it forms that upside down U shape. So our graph is going down. Go ahead and try this one on your own. So for this one, the first thing we need to do is pull out our axis of symmetry, which is the opposite of that value in the parentheses. So I've got x equals -2. So that goes 2 to the left, and we put in our dashed line there to help us with our symmetry. Then we have our vertex, so keeping that -2 point and pulling out our k value, which is -4. So 2 to the left and 4 down. Once again, on that dashed line, because our vertex should always end up on top of our axis of symmetry. Then I need to start plugging in points. In this case, I plugged in -1 and wrote that into my calculator. So -1 plus 2 parentheses squared minus 4, which gave you an answer of -3. That's that first purple point and the reflection point across the axis of symmetry. I skipped over 0. You don't have to go in order, but if you had plugged in 0, you would have gotten 0 plus 2 squared minus 4. And if you had done that, that would have given you another point at 0, 0, which then the reflection point for that one would have been at -4, 0. And then I jumped to the point 1, plug in 1 plus 2 squared minus 4, which gave us an answer of 5. And then its reflection point 3 spaces across the graph. So you could have had any of these 2 of those 3 pairs as your second points on the graph to help you make that U shape. Once again, we look at the front, we notice that there is no negative there, so my graph should be opening up, which in fact it is. When we go to standard form, we are still using those key features to help us graph. So once again, we need to start by finding our axis of symmetry. Remember, if you are in standard form, your axis of symmetry can be found by x equals the opposite of b over 2 times the a value. So what I'm going to do here is just quickly go through and label. A is equal to -4. That's the number in front of x squared. B is equal to 8. And then my c is equal to 3. So when I come down to do my calculations for the axis of symmetry, I'm going to have x is equal to the opposite of b, so -8, over 2 times my a value, which is -4. So I end up with -8 divided by -8. So my axis of symmetry is going to be at x is equal to 1. So we're going to put in that dotted line as our axis of symmetry. Once again, that's going to help us determine where the points are on the sides of our graph. Then we need to find our vertex. Remember, to find our vertex, we plug in x and solve for y. So we plug in this case, 1. So I'm going to have -4 times 1 squared plus 8 times 1 plus 3. When you plug that into your calculator, you are going to get an answer of 7. So your vertex point is at 1, 7. So we're going to go 1 to the right and 7 up. Then once again, we want to make sure that we know our graph is headed in the right direction. So that negative sign tells us that all of our points are going to be below because it's going to open down. The negative means we're going upside down. So then I'm going to start plugging in points. So I'm going to start by going just to the right. So I'm going to plug in 2. So in your calculator, you would do 4 times 2 squared plus 8 times 2 plus 3. And when you plug that into your calculator, you would get an answer of 3. So your next point is at 2, 3. So I go over 2 and up 1, 2, and 3. Then we use that axis of symmetry on the same vertical line. It is 1 to the right, so I'm going to go 1 to the left of that vertical line for my axis point. So then I need to go ahead and add another pair of points so I can continue to get that U shape. So I'm going to go after 2. I'm going to go ahead and plug in 3. So I've got -4 times 3 squared plus 8 times 3 plus 3. When I hit enter, I'm going to get -9. So I end up with the point 3, -9. So I go over 1, 2, and 3 and down to -9. That point is 2 spaces away from my axis of symmetry. So I'm going to go 1, 2 to the left. And that is going to give me my curve. Once again, a little bit more difficult for me to draw this on the tablet, but the general idea now being that we go through and connect our point with that upside down U shape. Again, noticing that our graph is going down. Go ahead and try this one on your own. So with this example right here, once again, we start with our axis of symmetry. So our A value is 0.5, our B value being -3, and our C value being -1. So we take the opposite of B, so +3 over 2 times A, which is 0.5. That gives you 3 divided by 1, giving you your axis of symmetry at x equals 3, so that dashed line. Then you plug 3 into your quadratic, and when you do that, you get an answer of -5.5. So your vertex is at 3 to the right and 5.5 down. Once again, right on top of that axis of symmetry. Now, as you go through and you plug in points, you could have started by plugging in 4 to your quadratic. As you do that, you would have gotten an answer of -5. So you could have had your first point be at at 4, -5. If you did that, your opposite point would be at 3, -5. I chose to jump straight to 5. At 5, you get 5, -3.5. So your opposite point is at 1, -3.5. You could have then jumped to 6 if you did that. You would have ended up with 6, -1. So your opposite point there would have been 0, -1. You could have then jumped to 7. 7 would have given you 2.5. And your opposite point would have given you -1, 2.5. Then I jumped all the way to 8. That gave me 8, 7. And my opposite point being -2, 7. So all of these points, all of these pairs could have been used as your second and third pair on the graph. You just have to pick out 2 of those 5. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.